main project is the title of the project is brain tumor using SVM and GLCM techniques. While coming to GLCM techniques, is a co-occurrence matrix. In this, we need to texture a feature extraction technique using image processing. So we used this GLCM in our project to extract an image, which analyzes how the pairs of a pixels in intensities occurs together in an image at a certain distance and a direction. The main motto of this GLCM, we have a raw images are very too large, and those are complex for direct classification. So in that situation, these GLCM helps converts images into a numerical features, nothing but image features. So the main thing, the main usage of this GLSCM is it will capture the texture information in the format of a contrast, homogeneity, energy, and a correlation. For this, which we have, which we are having, and mathematical formulas also. Which textures features are very useful for different images patterns. Mainly, we are using in healthy versus diseased images, which we also used for brain tumor diseases. And while coming to how we are used in this GLCM in our project, we have a set of input images where we need to convert into a scale. For each image, a GLCM matrix was using a specific directions and a distance. From that, from GLCM, we extracted features such as contrast, energy, homogeneity, and correlation. These extracted values formed a feature vector for each image. So these images are input to the classifier, which is nothing but SVM, to our in our project. So the main motto of the model of SVM and why we are using in this SVM is, as we know that SVM is nothing but a support vector machine. So which is machine learning algorithm used for classification. So in a web browser, we usually shows the classification when we are giving a diseased. For example, in our project, we have 4 types of tumors. When we are processing our image, when we are giving one type of a tumor, it will detect, it will go and background and which check the whether these images, these data is available in our model or not. It will check and it will process the image and it will display the output. And the and we have a question like, we have so many models like CNN models, basic models, VGL model, and so many models are available under machine learning. And why we are specifically using this SVM? Because it works with a small to a medium data sets, which like we also used modern, I mean, sorry, medium data set, which performs effectively with high dimensional features like GLCM features. And we included SVM with GLCM features in our project, and which really provides good accuracy and loss. As we know that if accuracy is more, loss will be very less. If loss is very less, which means that our model is working fine. And here and one more advantage of SVM is it will handle the non-linear data using a kernel functions also. And the main how we used SVM in our project is it will take the input from the GCL vectors as the input data. So the data was splitted into training and testing sets. The SVM model was trained using the training data. So during the training, SVM has a boundaries of different classes, which has really a training model was tested to data evolution format. So in our project, we used SVM to for classification, mainly a tumor classification, which are we mainly there will be 4 types. We used 4 types, and which we with SVM uh, we evaluated 4 types of performances. The final output was the predicted class for each images. And I mean, a generic overflow for this project will be, first a step will be a input image that will be already predefined with the GLCM. So after conversion of grayscale conversion, a texture feature extraction will be there, which is handled by GLCM. And after that, with SVM we used for classification, and the final prediction will be the classification of the tumor. Thank you. Basically, how our application will work, we'll see. After entering the command of Streamlight, it will directly redirected to the Streamlight application, where we need to give a input image. Okay. So here we need to browse the uh, browse the file images from the from our local directory, which is already downloaded from the Kaggle. So here we are giving glamour disease tumor. So we need to process the image. After processing the image, so it will check. It will pop up a message like to the model. So whether this image is there or not. So it will show the predicted class as glioma tumor. This is like our application will work. Losses of our SVM and GCLM model. The loss will be a zero point 0.4, which is negligible, and the accuracy will be 93%, which is a very good accuracy. Thank you.